Hello guys, and welcome back to another episode of chemistry. And of course, in this episode, we are going to conclude our study on radioactivity. It has been a very interesting journey. Okay, so please do not forget to like this video, do not forget to subscribe to this channel, and do not forget to keep sharing this video. All right, so I'm going to be looking at mass defect, mass excesses, and binding energy. Okay, I'm going to be looking at what mass defect, mass excesses, and binding energy. Okay, and also do not forget to know that this tutorial is brought to you by the O3 School JAMB app. It has all you need to succeed in your exam. If it were not so, I would have told you. Okay, it has all the past questions that you need for your study. Okay, it has what classroom feature that is structured according to your JAMB syllabus. A lot of people will not tell you that you need your JAMB syllabus to succeed. Okay, so if you have that app, you do not need to worry because the lecture notes, the class notes there, already they are structured according to your JAMB syllabus. So all you need to do is to just read and practice questions. Then likewise, there's the question search feature where you can search for questions according to topics. And what is more is that there's a mock challenge every Saturday that will conduct for all students that are writing JAMB for a particular year, compete with your mates, win prizes. Okay, get used to JAMB pass and likely exam questions. And what is more is that we release your result every Saturday, so you get to see your result and track your performance, thereby building enough confidence for the main exam. So please do not sleep on the app. Go to Play Store, download immediately, and start practicing your way to success. Just a little fee for activation, so please pay the sacrifice, pay the price, all right, and pass your exam at once. Okay, and if I be a man of God, I pray for you that this your JAMB will be the last JAMB. If this is your first JAMB, it will be your only JAMB. If you're writing JAMB for the second time or for the third time, as you're writing this, it will be your last JAMB in the mighty name of Jesus. All right, somebody comment amen in the board, in the comment section. Okay, so let's continue. We're looking at what mass defects, mass excesses, and binding energy. All right, and of course, I'll use an illustration, okay, to explain what this. All right, for example, let's say you have what you have an empty bank account, okay, an empty bank account. All right, and then you take what 4 500 naira notes. Okay, you take 4 500 naira notes, okay, and deposit it, okay, in your bank account. This bank account that is empty. All right, so you take 4 500 naira notes, okay, and you deposit it in your bank account. All right, so that means that you'll be expecting to have how much in your bank account? You're supposed to have what 4 times 500 naira notes, which is what 2,000 naira. Okay, so this is what you be expected to have in your account. All right, so now after you left the bank, after depositing, okay, you now discovered they're not saying you alert, okay, that you now have 1,950 naira in your bank account. I say, you will not say, hey, me, but I took 2,000 naira and deposited inside the bank account now. All right, I don't have ATM. They don't charge me for anything. I do not do transfer. So why would my money now cut like that? Some of you with tie wrapper, you cut chain. All right, you go to the bank and you report. Okay, you report the deficit, and you tell the bank that I deposited 2,000 naira, but I'm seeing 1,950. Okay, so that one is what's called is called mass deficit. Okay, that is mass deficit. That is deficit, because you are seeing less than you expect. You are seeing less than you expect to see in your account. All right, so now let's say the reverse is the case. Okay, then you now discover that after depositing 2,000 naira, you now saw you alert and you have 2,100 naira in your bank account. Some of you will cut chain and say, me, why will I deposit 2,000 naira and then they will add 100 naira? God forbid. Okay, you go to the bank again, you match. Okay, some of you will never do that in this life. The only time you complain is when your money cuts, okay? But when your money when they add profit to it, you will never go and complain. If somebody will transfer money to your account mistakenly, you will never go and report to the bank, okay? So let's say you are a good citizen now, okay? So you now go to the bank, all right, and tell them, it is 2,000 naira I deposited, but I'm seeing 2,100 naira. That means you are seeing more than you expected, okay, to see. You expected to see 2,000, but you are seeing 2,100 naira. Okay, so in that case, we call it mass excesses. Mass excesses. Okay, so to summarize this illustration, it means that what? When you see less than you expect, less than what? Expected. Okay, that is what? Mass what? Deficit. You are seeing what? Less than you expected, that is mass deficit. But you are seeing what? More than what? Expected. All right, more than expected, you call that what? Mass what? Excesses. All right, I'm sure you understand what the illustration. Okay, so that is what mass excess and what a mass what deficit. Okay, so this illustration that we just did is also what experienced when what nucleons. Okay, when nucleons form what? Nucleus. Okay, when nucleons, okay, form what? The nucleus. Or when the nucleus is what? Is formed from the nucleons. You know, the nucleons are what? Protons and what? And neutrons, okay? That are found what? In the nucleus. All right, so now when the nucleons, general, now form the nucleus, or when the nucleus is formed from the nucleus, this what? Illustration that we just what illustrated what is experienced. You see that the total mass, okay, of what? Of the nucleus, okay, is less than the subtotal of the individual constituents of the nucleons that make up what? This nucleus. All right, so you see that the total mass of what? Of the nucleus, of this nucleus, is less than the subtotal, than the sum total of what? Of what? The individual masses, okay, of the nucleons that make up this what? Nucleus. Okay, in that case, we are seeing what? Less than what? Less than what? Expected, less than you expected to see. So we are getting a mass, okay, of the nucleus that is less than we are expected to see what? According to the subtotal of what? The nucleus, of this nucleons in this what? In this nucleus. Okay, so that is what we call what? Mass what? Deficit. Okay, so this loss, the loss, okay, that you are seeing, the loss or what? The deficit that what we are seeing, all right, is what we call what? Mass what? Deficit. So we can define what? Mass deficit as what? As a loss, okay, loss in mass, okay, that is experienced when nucleons form what? The nucleus. Okay, so that is what? Mass deficit. That is mass deficit. Okay, so now, but according to Albert Einstein's theory of relativity, according to Albert Einstein's theory of relativity, you know Albert Einstein now into no book. Okay, so according to Albert Einstein's, some people say it's Einstein, or Albert Einstein's what? Theory of relativity. According to Albert Einstein's theory of relativity, he said that what? That mass and energy are what? Are interconvertible. Okay, they are interconvertible. Okay, according to Albert Einstein's theory of relativity, he said that what? Mass and energy are what? Interconvertible. That means that what? The loss in mass that you are experiencing when it comes to what? Mass deficit. Okay, it's possible that what? That mass must have been what? Must have been converted to what? To energy. Okay, it's possible that what? According to Einstein, that what? About Einstein, that what? That mass that was lost, or that deficit that we experienced, it's possible that what? It must have been converted to what? To energy, because what? Mass and energy are interconvertible. You can convert mass to energy and energy back to mass. Okay, so that mass that you are seeing that must have been lost when the nucleons form what? The nucleus, or when the nucleus is formed from the nucleons, okay, must have been what? Converted to what? To energy. That energy, okay, that energy that is formed, okay, when what? The nucleons convert to what? To nucleus, or when the nucleus is formed from the nucleons, is what we call what? The binding energy. Is what we know as the binding what? Energy. All right, simple as ABC. Is what we know as the what? As the binding what? Energy. Okay, so now, according to Albert Einstein, he said that the binding energy E is equal to what? MC square. Okay, he said that E, you must know this formula. All right, so most of you have seen this formula, but don't know how it comes about. Okay, so E is equal to what? Delta what? MC square. Where the E is what? Now let me find a space to write it out. Where E is the binding energy, or the energy released. Okay, E is binding energy, or energy released. Okay, and what? M is what? is what is the mass deficit. Is the mass what deficit. Okay, and C is the velocity of light. C is the velocity of light. The velocity of light is what? 3 times what? 10 to the power 8 meter per seconds. Okay, so it's as simple as ABC. Okay, so this is what data what this is what Einstein's what theory. Okay, so this is binding energy. E is equals to what data what MC square, where M is mass deficit, C is what velocity of light. Okay, and E is what is the binding what energy. It's as simple as what as ABC. Okay, so now likewise, we can what now what use this what illustration to calculate. We can calculate. We can look into what work out the mass defects. Okay, we can work out the mass defect and let's say binding energy of what of an atom or of a compound like what or of a nucleus like boron. Okay, boron of like boron. Let's look at boron, the boron nucleus. All right, let's work out the mass deficit and binding energy of boron nucleus. Boron nucleus. Okay, so now how many protons and neutrons does boron have? Okay, boron has what? 5 protons. Okay, and boron has what? 6 neutrons. Okay, so boron has 5 protons and what? And 6 neutrons. Okay, and this boron, the actual mass of this boron is 10.81 what? Atomic mass units. Okay, that's U, or we call what? Unified atomic mass unit. This is the actual mass of what? Of boron. 10.81 unified atomic mass unit. That is the actual mass of what? Of boron. And the mass of protons and neutrons is 1.0073 and 1.0087 respectively. Okay, so we want to really what calculate, we want to really see, okay, the mass deficit, okay, all right, in the boron what nucleus. Okay, so now let us continue. Now then, since we know what the masses of what of proton and what a neutron, we know the number of protons and number of neutrons in what in boron, then of course, and we know the actual mass. All right, this is the actual mass, the actual mass. Then that means that we can calculate the mass. Okay, the mass deficit. Okay, now so that means mass of what 5 protein. You can find the mass of what 5 protons. Not protein, no, 5 protons. Okay, that would be what 5 times what is the mass of proton? 1.0073. 5 times 1.0073. Okay, so let's use our calculator. All right, let me get my calculator. Where is it? Okay, so our calculator here says pressing. We're going to have what 5 times 0. Okay, no, not 0. 5 times 1.0073. That is what 5.0365. Okay, then we can now find the mass of 6 neutrons. Okay, since you know that 1 neutron is 1.0087, that was 6 times what 1.0087. That will give us what 6 times 1.0087. That is what 6.0522 from our calculator. Okay, so now having known that, now what is left? Okay, so we can then what look for what the mass. Okay, mass of 5 protons and 6 neutrons. Okay, that is the mass of this and this. You add them together. That is what 5.0365 plus what 6.0522. If you do that, what are you going to have? Plus 5.0365. That will give us what 11.0887. Okay, that is 11.0087. This is the mass that we got. Okay, so now can I calculate what the mass deficit, since we know the mass, the actual what mass, such that what mass deficit will be equal to what now? 11.0887 minus what? 10.81. All right, if you do that, I'm going to have minus 10.81. Okay, that will give us what now? A mass deficit of what? 0.2787. Okay, units. That's what atomic mass unit, unified atomic mass unit. Okay, so this is what the mass what deficit. Since we know the actual mass, and they will now find what the calculated what mass. All right, so that means it was what it was in excess before. All right, so now the deficit is what is this. All right, this is the deficit. Okay, so now if we find the deficit, then we can find what find what the binding what energy. So since you know that binding energy, that is what B E is what equals to what delta MC square. We know what M. We know M already. This is mass deficit. Okay, it's in what atomic mass units. To convert atomic mass unit to kilogram, we have done that before in a previous episode when we're discussing relative atomic mass. Okay, so we say to convert atomic mass unit or unified atomic mass unit to kilogram, simply multiply by 1.6 times 10 to the power minus 27 what kilogram. Okay, we said this in the previous episode far back, so please did not forget. You should not forget. Okay, so that is that. So we can convert what this atomic mass unit to what? To kilogram. Okay, so now let us see. Let us continue that. This is the mass deficit. We can now calculate what? The binding energy. The binding energy. Let's calculate the binding energy. All right, since you already know that what that binding energy is equals to what now? MC square. All right, we know our C to be 3 times 10 to the power 8 meter per second. Okay, then we know our M to be equals to what? Mass deficit 0.2787 times 1.6 times 10 to the power minus 27 kilogram. We're converting to kilogram now. So calculate that. All right, there's no need to calculate that. All right, so let's just put it into the formula. So that our binding energy now, E, will be equals to what now? M, that is 0.2787 times what? 1.6 times 10 to the power minus 27. All right, then times what? C squared. That is 3 times what? 10 to the power what? 10 to the power 8. All what? Square. Okay, so whatever the value is there, what we put that we put that down there. Okay, so because of time, we don't want to put a present calculator all through. Okay, so this will now be what the binding energy. Whatever you have is the binding energy. Please complete it and comment the answer in the comment section. Comment it in the comment section. Okay, so now I haven't done this now. Another thing we should note is that we can convert the mass defect in unified atomic mass. Okay, the mass defect in unified atomic mass can be converted to what? To million, or what one will call mega electron volts. Okay, that is what MeV. All right, so can convert it the mass defect in U to what? Or the binding energy, okay, to what? To mega electron volts. What we simply do is to what? To multiply the value that you get by what? 9315. Okay, once you multiply by this factor, you are going to have what? The answer in what? In mega electron volts. Okay, this is for the case where you'll be asked that your answer should be in mega electron volts. Okay, if I have to convert your answer to mega electron volts, simply multiply by what? 9315. Okay, so now let us go to the next part, which is what? Binding energy per nucleon. Binding energy per nucleon. All right, and binding energy per nucleon. Binding energy per nucleon is what? Is binding energy divided by what? Number of nucleons. Okay, binding energy per nucleus. This one is equal to what now? BEPN. That is binding energy per nucleon. All right, so this is what BEPN, binding energy per nucleon. All right, so what to simply do is to what? Divide the binding energy that you got the answer over what? Number of what? Of nucleons. Okay, so it's as simple as ABC. So we're going to take one question to what? Illustrate this. Okay, I'm going to put the question on the board as usual and make this part very, very fast, and we'll come back and we'll answer the question. All right, guys, you are welcome back. Okay, so let us take a swipe at this question and we are done for today. Okay, so now we're told that the discrepancy in mass, difference, okay, the difference in mass or the mass defect, okay, the discrepancy in mass in the formation of a certain radioisotope is calculated to be what? 0.3123 U. Okay, sorry, I didn't put that. 3123U given, okay, 0.3123 what unified atomic what mass. Now they say what given the atomic mass of the radioisotope to be 241, they say what determine the binding energy corresponding to the mass defect. Okay, it's as simple as ABC. So solution. All right, we are looking for what binding energy E, which is what delta what mc square. All right, we know our mass defect to be 0.3123U, which is same thing as well, 0.3123 times 1.6 times 10 to the power minus 27 kilogram. Convert it to kilogram. All right. Then of course that is there. That is that for that. Then we know C to be what 3 times 10 to the power what 8 meter per seconds. Okay. So that means we can calculate what our binding energy. Okay. That means that what E now, because of this value 0.3123 times 1.6 times 10 to the power minus 27. Then times what 3 times 10 to the power what 8 all what square. All right. So if you press your calculator, all right, that should give you what 4.5 times 10 to the power 1. I do not want to waste time. 4.5 times 10 to the power minus 10 joule. Okay, this is what our value will give us. Okay, so this is the binding what energy. Okay, so now they say determine the binding energy per nucleon for this nucleus. Okay, I will know that BEPN, which is what binding energy per nucleon, is what same is what binding energy divided by what number of what nucleons. Okay, so now that means our binding energy per nucleus will be what now 4.5 times 10 to the power minus what 10 all over what 241. We're given what the mass. Okay, we're given what the mass. So okay, they say what the atomic mass of the radioisotope is what is 241. Okay, so if it's not divide, press your calculator. Let me bring my calculator. Divide. I'm going to have let's calculate 4.5 times this. Okay, we're going to have 1.87 times 10 to the power minus 2 joule. 1.87 times 10 to the power minus what 2 what joule. Okay, so it's as simple as A, B, C. Okay, so we can decide to what to convert to what to mega electron volt by what by multiplying by what by 9315. Okay, so that's how what we do calculation on mass defects. Okay, so we have seen what mass defect, mass excesses, we have seen binding energy, we have seen binding energy per nucleon. Okay, so use this knowledge, look for questions on the O3 School JAMB app, like this video, comment and subscribe, and in the next class we'll be talking about what the most revered topic, okay, organic chemistry. Thank you for watching. See you in that next episode.